Hello, my name is Amit Kumar Vishkarma, IT branch, roll number 12. I am going to talk about distributed computing. It is a field of computer science that studies distributed systems, which are systems whose components are located on different network computers. These components communicate and coordinate their actions by passing messages to one another. And the challenges that come in this field is how do these separate components talk to each other reliably and efficiently. And the solution is various communication paradigms have been developed over time, each with a different level of abstraction. And now I am going to talk about my first topic, socket programming. Sockets are the lowest level abstraction for network communication. They provide an endpoint for sending or receiving data across a computer network. Think of it like establishing a phone line. You need to know the phone IP address and the extension port number to connect. How it works. The developer is responsible for everything, establishing connections, formatting data into bytes, sending, receiving, and interpreting the raw bytes on the other hand. Most commonly, it uses TCP for reliable connection-oriented communication. At server side, it creates a socket, binds it to an IP address and port, listens for upcoming connections, accepts a client connection, and sends and receives data. At client side, it creates a socket, connects to the server's IP and port, sends and receives data. Now I am going to explain my sample project which will explain how socket programming works that I have built with the two languages in C language which is a client side and for server side I have built it in Python. First I will run my server as you can see the server is listening on this IP address and now I will run my client. I will open my git bash and I will type the file name and will run the program. Okay, so here the server is sending the response and which is hello from Python server. It means the connection has been established to the server. Now I am going to explain my second topic, remote procedure call RPC. It is an abstraction layout built on top of sockets. It allows a program to on one computer to execute a procedure, a function, or a subroutine on another computer without the program needing to explicitly code the details for the remote interaction. Analogy: it is like calling a function from a library, but the library code exists on a different machine. The key features are it hides the underlying network communication, making remote functions look local. Now I will explain how RPC works. Client calls a local stub function. The stub acts like a placeholder for the remote function. Client stub packages and parameters. Data is sent over the network to the server. Server receives the request and unpacks the parameters. Server executes the function. Server packages and the result and sends it back. Then client stub receives result and returns it to the client program. And the key components of RPC are the client stub, which acts as a local placeholder that makes remote function call appear local, and the server stub, which receives the request, unpacks parameters, calls actual function, and the transport or network. It sends requests and responses between client and server. Now I will explain the advantages of RPC. It makes distributed programming simpler, hides network communication details, and support multi-language client or server systems. Now I will show the code of the RPC. I will first run the server. You can see the server is to run the server. I need to first go to the RPC directory, and now the client is running, and it asks for the first number to send. It basically needs two number and which will send to the server, and server will sum up the numbers and give the resultant as output. So my first number is 3 and the second number is 7, and after sending the request to the server, it responded with 5, which is the total sum of 3 and 2 that I have given. Now I will explain the third topic, which is Java Remote Method Invocation, or RMI. Java's native object-oriented take on RPC. It allows a Java object on one machine, JVM, to invoke methods on a Java object living on another machine. How it works? A remote interface, which is a Java interface, defines the methods that can be called remotely. The server implementation. A class implements this interface. And the next is RMI registry, a lookup service where the server registers its remote object. And the next step is client. The client looks up the object in the registry and can then call its methods as if it were a local object. Now I am going to explain it, it will how we can run this in my code. I'll first run the server file, so I have opened git bash, and I have to change the directory to the RMI folder, and now I will run my server by calling Java server command, and now I will run the client as you can see the result. The basically giving the result as 30, which is the sum of two numbers that is I have given in the client client.java file, and the server gives the response by adding those two numbers. My fourth topic is the common object request broker architecture, or CORBA, and the concept is it is a standard designed to facilitate communication between systems regardless of their programming language, operating system, or hardware. Working of CORBA. First step, interface definition language. A language neutral file dot ideal is created to define the interface of the remote object. Ideal compiler. This compiler generates server skeletons and client stubs in the target languages, example Java for the server, Python for the client. And the next is object request broker. This is the middleware that handles all the communication, finding objects, and routing requests.